Hello, math class. How are you? This is our first video for our remote learning. So what you're going to need right now is your purple packet and something to write with. So please take a moment to make sure that you have all of those items. If you need to pause this video, you should do that to go grab your stuff. And that is something to note as well. If at any point during the video I'm going too fast or you need to stop to catch up with notes, feel free to pause and make sure that you can catch up. All right, so I'm going to assume that you have everything in front of you that you need. So I'm going to go ahead and pull up our notes up here, and I'm going to hope that you can see them, but I will not know until I watch the recording of this video. So anyways, you should make sure that you have your 5.7 or your purple packet out, and we're going to be doing 5.7 today. Today, we're going to be talking about slope-intercept form. This is one of those things in math where mathematicians actually tried to make something helpful, where this form of an equation of a line will give you the slope and it will give you the y-intercept of the line. So it's actually here to help you and give you some information. Before we get into slope-intercept, I do want to talk about one other form that you're going to see equations of lines written in. So one of those forms is called standard form. Standard form doesn't actually give you any information really about a line, but it is going to be a form that we'll see, and we're going to have to rearrange these forms to get them into slope-intercept form. So standard form is written as ax plus by equals c, where a, b, and c are all just some numbers, okay? So a would be a coefficient for x, b would be a coefficient for y, and c would just be a number that's hanging out on its own. But anytime we have a, b, and c, these numbers they're just gonna be numbers, that's all. An example of how a line might be written, or an equation if it is in standard form, would be something like 2x plus 3y equals 4. So again, this is just a form that a line equation can be written in. Ax plus by equals c. So what we're going to see today is you're going to have some equations that are given to you in standard form, but we're going to want to get them into slope-intercept form. And the reason that we'll want to move them into slope-intercept form is because we're going to want the slope and the y-intercept. Because if we have the slope and if we have the y-intercept, we'll be able to graph the line. So slope-intercept form, some of you may remember, is written as y equals mx plus b. You might recognize y equals mx when we did direct variations the other day, or a couple weeks ago, but we are now adding a b into these equations. So in a y equals mx plus b form, the y's and x's just stay as y's and x's. If you remember, that's kind of what we're going to be seeing with equations of lines, and those are just representing different coordinates that we could plug in. But our m is going to be a value, and our m represents the slope of our line. The b is going to be another value, which is going to represent the y-intercept or the yint. This is going to be the point on the y-axis that the line intersects. So on like an easier note, just kind of practicing how to write these equations, is you might see some problems today where you are given that the slope of a line equals something like 1/3. And you might be given that the yint is equal to 6. And they might ask you to write an equation in y equals mx plus b form using this given information. So if we have y equals, and I'm just going to actually rewrite it right here, y equals mx plus b form, I replace the m. So I have y equals, my m is slope, 1/3 x plus B is my y-intercept. Y-intercept is given as 6. So y equals 1/3 x plus 6. So that would be just how I write the equation. So what we are going to be doing though with these lines is actually graphing them. So the steps that we're going to go through for graphing are going to be steps that you are certainly able to revisit these throughout the year, because this is the beginning of the end. Basically, we'll be graphing lines for the rest of the year. So these are important steps to keep in mind. So first of all, when we're graphing, if we think about graphing a line that's in slope-intercept form, this is super great because you have the y-intercept, you can plot that point, and you have a slope. So you can do rise over run from that point, plot some more points, and then you've got a line. So what that means though is we need to get it into this form in order to have the y and the b. In this form, what's really important is we can't get this information unless y is completely alone and on one side. So in order to do that, if for instance, we're given an equation like this, the first thing that we want to do is we need to get y alone. And we're going to need to get that equation into y equals mx plus b form, okay? So once we have this y alone, that means we have an m, we have a b, so we have a slope, and we have a y-intercept. So your second step is first to plot your y-intercept. So whatever your b value is, you're going to find that point on the y-axis, and that's going to be where the line intersects the y-axis. So we're going to plot that point. Then we're going to plot, I usually say like 3 to 5 more points, and I'll kind of talk about what that looks like, but like you don't just want to have one point of the line, you want to have a couple more. But we'll plot about 3 to 5 more points using the slope that you have. So whatever your m value is. And remember that the y-intercept is your b. Our last step, and sorry I don't have a ton of room here, is to just connect the points so that you get a line. If you need to take a moment and get these notes all down, go ahead and pause the video and just make sure you can catch up. I'm going to go ahead and move on to our examples. So for our examples today, we have 2. What you're going to be doing is you're going to write the given equation in slope-intercept form, and then you will graph it. So as an example, if I'm given y minus 1/2 x equals 2. I'm asked to put this into y equals mx plus b form, my slope-intercept form. So y equals mx plus b. And then I need to graph it. So remember, y equals mx plus b means my y must be totally alone. So when I go ahead and look at where my y is, this negative 1/2 x is also on the same side. So I need to get this to go away. Now, this is where those basics of algebra come in that we spent the first couple months doing. Because some of you might be tempted to like add 1/2 to one side or to both sides, or like divide by 1/2 or something like that. But remember, we need to move this entire thing right here. So what we're going to do is we're going to add 1/2 x to both sides. We need to get rid of this entire thing. What this will do is these will cancel. So I'm left with just y on this side. And then I need to somehow get these together and combine them on one side. Now, I cannot actually add these together because 2 and 1/2 x are not like terms. So your answer here is not going to be 2 and 1/2 x, okay? Also, you would never do a mixed number anyways, but they're not like terms, so I can't actually add them together. What I need to do is write them on this side of the equal sign in y equals mx plus b form. So I'm going to have y equals mx, my 1/2 x, plus the 2 as my b. If you wrote it as 2 plus 1/2 x, yes, technically that's correct, but it's a really good habit to make sure we actually write it with our x and its coefficient in the front, and then the b at the end. So y equals mx plus b. So in this equation, our slope is equal to 1 over 2, because that is our m, and our y-intercept is going to be equal to 2, because that is our b value. So our next step is we're going to go ahead and graph this. So I'm going to come down to our graph here, and I'm going to draw my axes. It is a good practice sometimes to just go ahead and label your axes, just so you can kind of remember which one is x and y. So once you have your axes labeled, our next step is going to be to plot our y-intercept, or our b. So I'm going to come up to my equation, and I see that my y-intercept is equal to 2. So on my graph, I find my y-axis. I start at my origin, and I'm going to count to positive 2, and I'm going to plot a point right there. That is a point. My next step, is to plot about 3 to 5 more points using our slope. So my slope is 1 over 2. Remember that that's rise over run. So from this point, I will rise 1, I will run 2. Rise 1, run 2. Now I want to make sure I get some more points over here. What can be tricky is at this point, if you're going like in this other direction, you're not going to rise 1 and run 2, because all of a sudden you're going to get a V and you're not going to have a line. So you need to remember to kind of go in this direction, which means you actually drop 1, but still go over 2. Drop 1, go over 2. Once you have all these plotted, you're going to go ahead and draw a nice straight line. Some of you may want to use a ruler. Not saying names. And then you have your line. So you're all set. So we're going to go ahead and start our second example. Remember, if you need to pause this at any point, please feel free to do so if you need to catch up. All right, so our second example, I'm going to give to you. If we were in class right now, I would give you this example and I'd ask you to try this on your own. So what I would highly recommend is that I give you the example and you go ahead and pause the video and actually try it on your own. I know that some of you might not actually do that, and I can't actually enforce this. So it's a good practice if you go ahead and pause and try this on your own, but also I can't make you do that, but also you should. So our next example is negative 3x minus y equals 1. So my first, so right now, if you want to pause, try this on your own, please do that. And if you actually paused it, now we'll go over the answer. If you didn't actually pause it, we'll go through and talk about this, but you should have paused it and tried it on your own. So anyways, I have my equation right here. My first step is to get it into y equals mx plus b form, which means I need to get my y alone. So I'm going to look on this side, and there's a lot of other stuff over here. I'm going to start with this negative 3x. I'm going to add 3x to both sides. What that does here is it cancels. And I'm left with negative y. Now that's a big mistake people often make, is they forget this negative. You want to keep the sign with the variable, and negative y is going to follow you down. Equals 3x plus 1. Remember, 3x and 1 are not like terms, so my answer is not going to be 4x. I need to make sure they stay separate. And I'm trying to write it with the x in front, so mx plus b. Now the thing is here, my y is not alone. So I have this negative sign. I need to make sure that I get rid of that. Remember that in order to get rid of that negative, I'm going to divide by negative 1. Whatever I do to one thing, I must do to everything. So I have to make sure that I'm actually dividing every single term by negative 1 in order to make this work. So basically dividing by negative 1 is just going to switch the signs of everything. So negative y divided by negative 1 will leave you with y. 3x divided by negative 1 leaves you with negative 3x. 1 divided by negative 1 leaves you with negative 1. So, sorry, I don't have room here, but when I take a look at this, I need to identify what my slope is. So if I have y equals mx plus b, my slope is my m. So my slope is going to equal -3. Now, one thing about the -3, and I'm going to write this actually down here, is if I have a slope that is -3, remember that slope is rise over run. This is not in a fraction form though. So if I have any like whole numbers like this, it is helpful to turn it into fraction form. So if I have -3, if I wanted to write that as a fraction, that's equal to -3 over 1. So I'm going to rise 3, run 1. And what's important here is that negative sign. So I need to make sure it's in a negative direction. So I have my slope as -3. My y-intercept is going to be my b. So y equals mx plus b. So my y-intercept is equal to -1. All right, so we're going to go ahead and take this information and graph. Remember, if you need to pause for a moment, please feel free to do so. So I'm going to graph. So I have my y-intercept equal to -1. Remember, that's what I start with. So I start at my origin, go down to -1. I plot a point. My slope is -3. Remember, that's rising 3, running 1 in a negative direction. So this is one thing to be very, very careful about. So if I rise 3, 1, 2, 3, if I were to run in this direction, that line would now have a positive slope. It'd be going in the positive direction, but this has a negative slope. So I rise 1, 2, 3, and I move 1 in the negative direction. If you think about this x-axis, I'm running in the negative direction, so towards the negative numbers. 1, 2, 3, point. And now I'm going to go from this point, so 1, 2, 3, and go over. Now that was in a positive direction, but remember I'm continuing so that this line stays straight. Once I have these, I'm going to go ahead, plot my point, or connect the dots. And that is my line. One way to double check again the negative slope thing is remember that if I were to write the letter N for negative, the line follows that letter N. Okay, so that confirms that I have a negative slope if I can write that letter N for negative and it follows the line. All right, so you're going to want to make sure that you have these notes completed before our next class, because we will be doing all practice with this. We'll start class with a warm-up and then we'll go ahead and get into practice. So if you have any questions, if any of these notes were confusing and you didn't understand things, obviously make sure that you come during office hours. Let me know, email me if you have questions. Anything that I can do to help to make sure that you're coming to class ready to go. So yeah, I'll see y'all later.